Hello. Okay, today we're going to be working in 1.1 and 1.2. And our first question, we have decide whether the graphs A, B, or both represent a function. And here we can see those graphs. We can zoom in. If we just click that magnifying glass, makes it a little bit bigger. So this graph A is in black. It's a parabola on its side. And this graph B looks like a trigonometric function, a sine curve or cosine curve. Anyway, we want to know if we draw a vertical line, it should only cross the graph once. And if we draw a vertical line, it will cross graph A twice in several places. All it has to do is cross twice once in any place, and it's not a function. So B, however, would only cross once. So we're going to say that B, the graph B by itself represents a function. All right, question 2. We want to determine appropriate domain of the function. Okay, and then it says an appropriate domain is blank. We have two parts. After we do appropriate domain, we want to identify independent and dependent variables. Okay, so this one tells us a stone is thrown up from the ground, speed of 25 meters per second, time t equals 0. The distance is in meters. Above the ground, neglecting air resistance, is approximated by this function. So we're given f of t equals 25t minus 5t squared. T is in time, and our f of t is going to represent distance. So remember, x and y, domain and range. So that tells me right now t is the domain that's in the position of x. The y value is my range, and distance is going to be the range. Okay, so right now we want to find an approximate domain. So since this is a real world object, we want to know, I guess, when that thing hits the ground again, because we're throwing up an object and then it's going to come back down and hit the ground. So we start with f of t is equal to 25t minus 5t squared. Okay, so to approximate a appropriate domain, this graph, since the highest degree is a square, this lets me know we're dealing with a parabola, which tells me we start at time 0. We want to know when it hits the ground again at 0. So that means I'm going to be plugging in a 0. You'll notice mathematicians love to use 0. It's easy to work with. In order to solve this, we're going to have to factor. So I'm going to factor out common factor. Let's just factor out a 5 and a t. Factoring out 5t, 25 divided by 5 will leave us with 5, and I pulled out the t. Minus 5 divided by 5 is 1, and we had 2 t's, we pulled out 1, so it'll be just 5 minus t. 1 is understood. Okay, so now that we have it in linear factors, we're going to set each equal to 0. And we're going to solve for t. So to get t by itself, we're going to divide by 5. 5 divided by 5 is 1. 0 divided by 5 is still going to be 0. So we get 0 equals t. That's the initial starting point. Here, I need my variable positive, so I can just add the t to the other side. Positive and negative t will go to 0. 0 plus t will give me t, and that will be equal to 5. So it looks like this graph goes from 0, and then it's in the air for about 5 seconds, and then it hits the ground over here after 5 seconds have passed. So the question or the answer box says to put it in interval notation. So since this is real world, if you put it in parentheses, that would be incorrect, because we actually do start at 0, we actually use 0, and we actually do reach 5. Parentheses would indicate we don't actually use the endpoints, and in this case we do. So you want to use a square bracket that indicates that the 5 and the 0 are actually included in all the numbers in between. So I'm going to use the keyboard and just do the square bracket 0, and then 5, independent variable, so that would be X independent. That would be the T that's in position, and then the only other one we have is D, that has to be the dependent variable.